participants.
Yes. Sir, Michael sir, you are very much welcome to our NIT Arunachal Pradesh. Sir, welcome to our institute. And sir, and all the other participants, all the faculties, all are welcome to our NIT Arunachal Pradesh. So let us start the session. So this is one of sir, everything is online. So we are inviting them, everyone in online basis. And sir, please start the session, sir. Yes, sir.
Okay. Yes, no, ma'am. We will invite them regularly also once this problem comes down.
Yes,
sir.
After the corona issue is over.
After pandemic.
Yes, sir.
Yes, sir. Michael, sir, we are going to invite you formally, sir, to our Department of Biotechnology. You will have to come, sir. And I have also started some computational work, sir. So I am going to collaborate with you, sir. And sir, you are very much welcome to our department. Not only sir, our Michael sir, and all the other faculties, they are also invited cordially to our NIT Arunachal Pradesh, and also to the Department of Biotechnology, and also the Basic Science Department. So Vanav sir, being from Basic Science, sir, I am telling you about your department also.
Thank you, ma'am. Thank you, ma'am.
NIT Arunachal Pradesh. After this pandemic, we are going to start inviting all of you formally in our NIT. Thank you so much.
Yes, sir. Thank you, ma'am. Thank you, ma'am. Sir, please, sir.
Okay. So what did we discuss today's morning lecture? (3D structures). Okay, what is the database which contains protein 3D structures? PDB, right? Yeah. Approximately how many structures are deposited in PDB? Uniprot is for the protein sequences and PDB is for protein structures. 169,000. Okay, that is fine. Okay, so then we discussed about a visualization tool. Okay, which tool I discussed? Pymon, right? How many of you installed Pymon in your computer? Okay, done. Okay, what are the other structure-based parameters we discussed? Contact map, yes. Contact order. Surrounding hydrophobicity, and long range order, and so on, right? Okay. Okay, I'll share my screen. Okay, I have two options. One option is I can show a demonstration and you can do in your computer. And second option is we can also tell you exactly, we'll show how to do it and you can do on your computer. For second option, but both options anyway, you need to have the Pymon installed to your computer, otherwise you cannot do that. Fine. So I show the questions and then I'll ask my students to demonstrate the questions and show how to get the answers. Okay. Okay. I have three parts. First part is regarding about the visualization of proteins and then getting the structures in different colors and then zooming the structures, cartoons, and so on. And second part is regarding some calculations, find the distance, angles, diagonal angles, and so on. And the third part is some extended analysis like the comparison of the protein structures and the alignment and then protein ligand interactions and so on. Okay. Okay. Which one you prefer? I think you need to show the PowerPoint slides, or just you want to show exactly the online demo? Okay, so anyway, okay, online demo will be better. Okay, then I will go with the online demo. Okay, so I will stop this and I'll ask my students to okay. Then can you do this? Start the question number 1, and then I can show to the participants.
Yes, sir. Okay.
Okay. So if somebody has completed the question, then tell okay. Then we'll go to the next one.
So coming to the first part. So first question is to get the PDB files from the protein data bank database. So for that, you have to go to the PDB database. So here in the search box, you have to enter this PDB codes 1ALC. Then click the search icon button. So it will redirect to the respective entry page. So here you have to download the PDB format of this protein structure. So for that you have to click the download option, the download files. Here you have to click the PDB format. After clicking this PDB format, you will see this PDB file is download and save in your local computer. Is everyone follow?
Are you able to download the structure 1ALC?
Yes.
Yes.
Yes, sir.
Okay, then do for the other two structures. Okay, the question is first get the PDB files for 3 structures: 1 ALC, 4 LYZ, and 1 TIM. Once you're done, let us know. We'll move on to the next question.
So anyone has a problem to download the PDB files? Okay, done. Okay, coming to the second question. Open the file 1TIM and show the cartoon cell in the PyMol visualization tool. So for that, you have to open the PyMol. So in the PyMol, you have to go the option file option, then select open. Then you have to go to the directory where you kept your downloaded PDB files. Then you have to open the 1TIM PDB file. So anyone having issue with this one? If you have any problem, you just message in the inbox. What about others? Only Rasmi is replying for all the message for everything. So what about others? Okay. So then you have to select the option called select, it denoted as the yes. Then go to as the show option. You have to select the cartoon state. So you will get these PDB structures in the cartoon representation. So everyone done with this one? Okay. So coming to the third question. So give different colors for different chains. Then say how many chains are present in the PDB structure. So for that, you have to select the option called color. It denoted in the C. So this option you can find in the right side of the panel in the PyMon. So select C. So it's also known as the color. Here you have to give the color by chain. You have to select the chain options, then give. Then you have to select the first option. So now you gave the color based on the chain name. So after seeing this picture, so how many chains are present in this particular 1TIM PDB structure? So anyone guess? Okay, too good. So in this PDB structure there are 2 chains. So in each chain represented in the different colors. Okay, coming to the fourth question. Remove one chain. So for that, you have to come the right corner of the PyMol software. So here see the selecting residues. You have to click on the residues. It will change. It will change into the chains. Then after changing into the chain, you have to select any one of the chains. So it will choose the complete chain of the PDB structures. Then you have to go this select object. It denoted as the SCLE. Here you have to click the H. Then hide give everything. So now it is showing only one chain of the PDB structure. Is anyone has problem with this one?
If any question, just ask us. We are happy to help you. Once you are done, just yeah.
Okay. Okay, I'm going to repeat again. So this is the initial PDB structures. So now I want to remove one chain. Now I want so for that, in the PyMon software, you go to the right corner option. There is name called selecting. After the selecting, there will be the so many options like chains, residues, atoms. So here you have to click when chain comes. Once chain comes, leave it. Then you have to after choosing the chains, then again you have to come to the workspace where you have to choose any one of the chains. So now I'm clicking this. Now I'm clicking the chain. Then again I have to go to the object called SCLE. Here you have to hide this particular chain. So for that, click H. Then give select option called everything. Clear? Is it clear now? Okay. Okay, what about others? Okay. What are the full forms of? Okay. The A for action, S for show, H for hide, L for label, C for color. So when you are clicking the A, you can see the abbreviation for this each term.
It seems you missed my morning lecture. I explained everything in my morning lecture.
Okay, coming to the fifth question. Identify the secondary structures with different colors. So again you have to, for that again you have to go to the color option. Then you have to select by SS. SS means secondary structure. So now the helix are colored by red color, sheets are colored by yellow color, and green color represent the loops. So everyone got it? If you're not able to follow, just put message in the inbox. We can help you. Okay. Okay, I'm going to repeat again. Okay, I'm going to repeat again. Listen. So again, you have to go to the color option. Then you have to select by secondary structure. Then you can choose any one of the color. Is it clear now? Okay. Okay, coming to the next question. Zoom and rotate to get the complete views of the protein structure. So for that, you have to click the protein on the protein structure in the structure element. Then with clicking the mouse, you move the mouse. You have to hover your mouse. You can get the you can rotate the protein structures, and also you will get the more view on the protein structure. How to unhide the in again? Okay. Then again you have to go to the option called show. Then select cartoon option. That's it. Ask me. Are you able to unhide the chain? Okay. So is everyone done with the sixth question? The zoom and rotate the protein structure. Okay. So seventh question is to show the sequence of the protein structure. So for that, you have to you have to go this display option, where you have to choose the sequence option. So after selecting the sequence option, you will get the sequence in the workspace. So this is the complete sequence of this, but this one TIM protein structure. See, everyone done with this one? Okay. So the next question is, select the residues from 21 to 26 in the PDB sequence. So for that, again you have to come to the right corner of the your Pymal workspace where the selecting option is there. So again you have to click on the selecting option till when the residues comes. So now residues came. So then again you have to go to the sequence. So you have to select that sequence 21 to 26. After selecting the sequence, after selecting the such of sequence, then again you have to go to the 1TIM object, select the hide, go to the hide options, then give hide everything. Now you can see only the selected region of the PDB sequence. Then again, if you want, then you want to show the structure of this region, you have to go to the select object, select object, then go to show us sticks. Everyone able to do this one? Okay. Okay, I'm going to repeat again. So to select the such of residues, you have to go to the right corner of your Pymal workspace where the selecting option is there. So the selecting options, you have to select the option called residues. If you click on that selecting options, you will get the residues options. So after selecting the residues option, then you have to go to the sequence panel. Here you have to select the stretch of residues from 21 to 25, so 26. So now we select the residues. Now go to the 1TIM object, give hide everything. Now you can see the workspace, only these selected region residues are marked. If you want to show this region with some representation, again you have to go to the select object, then go to the show options, then view the regions as a sticks representation. Everyone got? Okay. What about others? Okay, the next question is color the selected residues based on different atom types. So for that, go to this again this silly object, then go to the color option, then select color by element. So now you see these carbon atoms are colored by green color. Oxygen atoms are colored by red color. Then nitrogen atoms are colored by the blue color. So anyone has issue with this one? If you have any issues, you just ask me unmuting your mic. Okay. We are getting response from only. We are getting responses from only 2%. What about others? Are you able to follow me?
How about others? We did not hear anything from other participants. Can some others tell something? Maybe a couple of more. Okay.
Okay. If anyone has issue with the first part of the questions, if you have any issues with any questions, you can ask me now. So right now I am going to move into the second part. So before that, we will finish the first part. Okay, moving on to the second part of the session. Sir, can you do all the steps in the software? Yes, you can do all the steps in the software. Right now I'm doing the PyMod software only. I'm not using anything else. I am working on the PyMod platform only. Dipton, are you finished the first part questions?
Hello.
Yeah, yes.
Hello. Yeah, yes, sir. Yes, sir. I can finish.
Okay. So coming to the second part. So identify the at least one salt bridge within the protein and list the details of the interaction.
Hello. Yeah.
So for this question.
No, I'm not available because already. Sorry.
So basically, before that, I would like to explain what is a salt bridge. So basically, the salt bridge, this is a type of non-covalent interactions. It formed between the positive charged amino acids and negative charged amino acids. Specifically, these nitrogen atoms from the positive charged residues and oxygen atoms from the negative charged residues are participate in this interaction. So now I am going to give demo to how to visualize this interaction in the PyMod. So for that, you have to select all the positive charge residues in your protein. First, this is the first step. So before doing that, you remove this this 3 object. So go to action, then give delete. So again, you go to the 1 TAM object, then show us the cartoon. So for that, first I need to select only the positive. First, I have to select the positive charge residues. For that, you have to write the command in the menu bar in the menu bar panel. So here you have to select here you have to enter the command like select, then the object name. Here my object name is positive, then comma, then give space. Within the bracket, you have to select the residue names like arginine, lysine, and histidine residues. So To select the positive residues in this particular protein, you have to type this command in this command line. So after typing the command, you just give the enter. So it will select all the positive charge residues in the particular protein. So is everyone able to do this one? If you have any issues, you at least put a message in the inbox. Okay, right command again. Okay. Select, then object name. That object name will be anything. Here I input a name called positive, then comma, then space, then open the brackets. Within the brackets, you have to write residue name like res in the form of RESN, which I wrote in this command line. Then space, then mention all the positive charge residues with within the bracket. Whether can you put it this command in this inbox? Yeah, thank you. So anyone has issue with this one? Okay. So next I have to select all the negative charge residues in the particular protein. So for that, like you have to write the command select, then object name. Here I put object name is called object name is negative, then comma, then within the bracket you have to write res_n, then name of the negative charge residues name. Then after typing the commands, you give the enter. So now you see the right side of your Python workspace. There are two objects called positive and negative. The positive object has all the positive charge residues in the protein, and the negative object has all the negative charge residues in the protein. See, everyone done with this step? So any problem, you put in message. We can help you. Syntax error.
S will be small, S will be lowercase. Select positive in which S will be lowercase.
Okay. So now I have now I have selected all the positive and negative charge residues. Now I am going to find now I am going to find the salt bridge in this 1TIM protein. So for that I have to write the command like distance, then space, then object name is salt bridge, then comma, then I have to select both positive and negative charge residues object. Then you have to mention the distance cutoff. Here I am mentioning the distance cutoff is 4.0. Then give enter. So now you see. Now you can see this workspace. all these salt bridge interactions within this protein. Then further, if you want to interested to these specific interactions, you can select the particular residues in particular interacting pair of the residues. Then you can visualize it. So here I am showing only here I am showing the complete salt bridge complete information of the salt bridge in this particular protein. So anyone has issue with this one? Okay. What about others? How many of you finished this step?
Shall we move, or you want to discuss again? Yeah, because already we finished for 30-40 minutes. Now it is very difficult to start from the beginning. Okay, Krandi, continue with the next one.
Yes, sir. So coming to the next question, to identify the any hydrophobic interaction in the protein and list the details of the interaction. So for that, so you have to do it similar in the way what you did in the salt bridge. So before that, you delete all the objects, go to action option, then choose delete selection. So to find the interaction between the aromatic residues, so I need to select the aromatic residues within this protein. So for that, you have to enter this command like select then object name that you can give any name. Here I wrote aromatic, then comma, then open the brackets, then type resin, then give the all the aromatic residues, phenylalanine plus tyrosine plus tryptophan plus histidine. After typing this command, give enter. After entering this command, you can see all the aromatic residues are selected in this workspace, which are represented in the red color dot. So anyone has issue with this one? Whether can you put in the command the inbox?
Yeah, give me a second.
Again, the similar way you have to give the command called distance. Then you can find the find the interaction between the aromatic residues within this within the desired cutoff of some distance. So coming to the next question, label the residues using the atom name and show the van der Waals radii. So for that, you select any of the residues. So let's say I'm going to select the residues number 21. So for that, you can select the before selecting the residues, you have to go to the right corner of the Python workspace. Then you have to change the options called to residues. After that, you have to come to the sequence window where then you have to select the residue. Here I am going to select the using residues. This is in the position 21. So after selecting this residue, you go to the 1TAM object, go to hide options, give hide everything. Then go to CD object, choose the label, then give residue. So see here, I choose the residue number 21. Then I am going to visualize this residues in 6 representation. So for that you have to go to the show option, then show as stitch. So everyone done with this one? Are you able to select single residues from these in the Python workspace? Okay. Then go to the CD object. Go to CD object. Label the residues with the atom names. So go to the label panel and select the atom name. So here you can see the residues labeled with the atom name.
Kulindi, can you zoom it? Action and zoom. Then it will be more clear. Action, go to A.
Yeah,
Oh, here also.
Go to label option and choose atom name. So now you can see each atom in this particular residue are labeled with the different atom names. So after that, you have to go to the label. Again, you have to go to the label option. Then select van der Waals radius. Here you can see the van der Waals radius of each atom for this particular residue. Whether my screen is visible?
Yes, it's visible.
Okay. This black background is fine. Shall I switch it into the white background?
Yeah, it's perfect. It's not an issue.
Okay. So anyone has you see this one? Okay. What about others? Only Reshmi is doing. Okay. So coming to the next question. So to compute the distance between two atoms, between the atom of Cg and Cd2 in the leucine 24. So for that, you have to select the residue 24 as you did the earlier. So before that, you have to delete this silly object, go to action, then choose delete selection. So after that, go to only after that you have to go to the right corner of the Python workspace, then choose the option called residues in the selecting. Then you have to go to the sequence panel, then select the leucine residue. Then show that leucine 24 as the 6 form. Then label the residue with the atom name. Now the question is, we have to compute the distance between the Cg and Cd2 atom. So in order to calculate the distance between the any two atoms, you have to use the option called YZ. It will be in the top menu. In the YZ menu, you have to select the measurement. Then after choosing the YZ, you have to click the two atoms. First one is Cg. The second one is Cd2. So now you can see these two atoms are separated by the 1.5 Armstrong of distance. Here you can label the distance with the with some representation. For that you have to go to the measure. With the measure, go to show options, select the dashes. Everyone done with this step? If you have any issues, you go post your message in the inbox. So everyone done? Whether am I audible?
Yes,
fine.
yes. Is there any doubt?
Anyone has any doubt? Okay, done. So coming to the next question, compute the angle formed by the atoms CD1, Cg and Cd2 in leucine 24. So for that again you have to go to the YZ option, select the measurement. After selecting the measurement, you see in the right corner of the Python workspace, if you click the measurement mode, you can see several options like distance to ring, angles, diagonals. There you have to choose the option called angles. After selecting the angles, you have to select the 3 atoms. The atoms are CD1, CD and CD2. So CD1, CG and CD2. So now you can see the angle between these 3 atoms. The angle is 109.9. So is everyone able to reproduce the same result? Okay. So next question is compute the diagonal angles of Lewis 24. So the to calculate the diagonal angles, you need to select the 4 atoms in the Lewis 24. So before doing that one, you have to delete the other objects. So to delete the object, go to action option, give delete. So to calculate the diagonal angle, again you have to go to the YZ option, then select the measurement. In the measurement, you have to choose the diagonals. Then you have to select the 4 atoms. Anyone has issue to calculate the diagonal angles? So I am repeating same thing again. Go to wizard option, then select measurement. In the measurement, you have to select the diagonals, then select 4 atoms. So you need to select the 4 atoms to calculate diagonal angles. Okay, what about the others? Okay, so coming to the next question, you have to change your workspace. You have to change your workspace color from black to white color. So for that, you have to go to the main option. In the main menu bar, you have to select the display option. In the display option, you have to go to the background. In the background, you have to select the white. So I am repeating the same. Go to the menu bar, main menu bar, select the display. In the display options, you have to select the background. From the background options, you have to select the white. Okay, that's it. Okay, the next question is to make the high quality picture using the PyMon. So to make the high resolution picture, you need to use the ray command. So again, you have to go to the main menu bar, the command box of the main menu bar. Type ray, RAY, then space, then give the image size. Then can you post the comment in the inbox? Okay, thank you. Everyone done with this ray command? If you have any issues, just put it in the message. Okay. So coming to the next question. So B factors to see the flexible and rigid region in the PDB. So for that, I asked you to open the PDB file called 1ALC. So before that, you have to delete this object 1TIM. Go to action option, delete the object. Then go to again the file menu. Then open the PDB file called 1ALC. See, everyone open the 1ALC PDB in the file browser space. Okay. So to find the flexible region in the PDB structure, go to action option. In the action option, there is an option called preset. In the preset, you have to select the option called B factor putty. After selecting that option, you can see the flexible regions are colored by green as well as blue color. The rigid regions are colored with the dark blue color. So is everyone able to get this picture? Okay. So basically, it gives the information about what are the regions are flexible in your PDB structure. So what about the others? So I am going to finish the second part of this session. So if anyone has any issues within this part 2, you can ask now. Okay, coming to the part 3. So now I am going to export the images from the PyMall software. So to get the image format from the PyMall software, you have to go to the file option, then select export images as what file formats you need. So here I am choosing the PNG format. So after selecting this one, you have to give the location of the file path, then enter the file name. So now you can see the PDB structures are exported as the PNG file format. So everyone able to export the PNG file from the PyMall? Okay, if you have any issues, you post your message in the inbox. Okay, coming to the next question. So you are already working on this 1A LC PDB file. Then now you have to open the one more PDB file called 4LYZ, which you have downloaded in the first question. So again you have to go to the file option, open, then select the 4LYZ PDB file. So after selecting the PDB file, you can see there are two structures are there in the PyMall workspace. Is everyone able to open these two structures in the PyMall workspace? Okay. So the next question is align these two structures. So to align these two structures, you have to go to the action option. Then select align to molecule with 4LYZ. So you can see now there are these two PDB structures are aligned in the PyMall workspace. See everyone following? Okay. So after aligning the structures, you can see this main menu bar. You can see the RMSE between these two structures. Here the RMSE is 0.9. So which means these two structures are closely related, very similar structure. Then the next question is save the aligned protein structure. So here to get this alignment structure, you go to file. You can save as a session file. In the file menu, you have to select the save session. Here you can save the file as a PyMall session file. After saving this file, you can use this file at any time. This align file has the alignment information of these two PDB structures. So everyone's done export the aligned PDB structures. Okay, do you have any questions? You can ask now. So we are done with part 3. So if you have any questions about the PyMol, you can ask now.
You're done, right?
Yes, sir.
Yeah, so we have done the mod. Okay, we have covered different aspects, display options, and then you can use the high-quality figures and with some calculations and all. But this morning I discussed about the PyMod and then gave you some references. And you go to the references, so you can get more information. And you can also do a lot on this PyMod, for example, electrostatic potentials, mutations, and the energy, interaction energy. And we can use the PyMod successfully on various aspects, right? So you can just go through tutorials and then it's you can use the PyMod as whatever you want. It is a lot of options and you can do that. Yeah. If you have any questions, just you feel free to ask us. We are all here. And yeah. So anyway, I hope you had a good time for attending all the lectures. And if you need more details, you can watch my NPTEL videos or read my books. So that will be helpful for further understanding and the proceed for research as well as in your studies. Yeah.
Yeah, sir. Thank you for this session. Yeah, participants, if you have any questions, you can ask sir. I think you must take a more interaction during the regular sessions in future. Okay, you can ask questions if you have any. So, yeah, if participants are not having any questions, then let me thank the expert and his team, Professor Dr. M. Michael Gromiha sir, from Biotechnology Department of IIT. So it has been a very pleasant travel along with him through this biotechnological concepts right from day one to today. The teaching has been very rigorous, I believe. It was very rigorous, and participants were put into some stern test. Yeah, it is a bit difficult to grab everything at a first go. Anyhow, the Atal platform will be providing you the recordings, and of course, you can watch them in YouTube also, maybe after a few weeks or so. So you can watch them, and again you can enhance or polish your skills. So the coaching was really rigorous, and I once again, from my bottom of the heart, I thank him. So look, it's not so easy to get an opportunity like this from such a tall figures. Spending a lot of time, 6 hours, maybe small for some of us, but it's very valuable for them. They can do a lot of such things. So I really thank on behalf of our director, Professor Dr. Pinkeshwar Mahanta sir, NIT Arunachal as a whole, Department of Basic and Applied Sciences, Department of Biotechnology, and on behalf of AICT, who has sponsored this program. And of course, as a coordinator, I am really thankful for him. It all started when I took up his NPTEL course. Then I got interested, and there was one international conference for which he has invited. So I thought I will attend that, and there I met sir, and I have requested. So then everything happened. So I'm really thankful for him, and as and when opportunity arises, sir, we will be inviting you to our institute. So
Yeah, great to come.
yes,
Yeah.
yes, sir, yes, sir. But I know your time is very precious, sir. Sir, if you can take, say, maybe 5 minutes from the participants to thank you, I will be grateful, sir, because so much effort has been put. So really, if you participants join us to thank you and your team, then I would be happy. On records, let it be there, because it's not so easy as far as you are concerned. So participants, please join in. Please thank the team of
Sir,
yeah, yeah,
yes, sir. One of
yeah.
I myself from Department of Biotechnology, sir, the Arunachal Pradesh. I'd like to thank sir a lot, means Michael sir, and his whole team, because sir, this is very much important now. Bioinformatics, uh, in simulation study, in silico study is very important in biotechnology, in the field of biotechnology. Especially, I'm working with plant biotechnology. So I'm working, sir, Michael sir, I'm working with the secondary metabolites and the bioactive compounds of the different plants. So this docking is very important for my field, sir, especially after conducting the LCMS, GCMS plants, sir, the medicinal and aromatic plants of Arunachal Pradesh. Because as you know, sir, this is a biodiversity hotspot region of the world, the 12th mega diversity hotspot region of the world, Arunachal Northeast as a whole. We can target some very interesting focused for the different kind of diseases like diabetes, even the viral diseases, even coronavirus, sir. Now, recently, I am working with a plant called Hutunia cordata. It is directly targeting COVID-19, and I have gone through a few papers from China too. And sir, one more thing regarding the biodiversity of China, Korea, Japan, almost the plants present there are very much similar to this part of India, sir. So that is why if we can work out the, especially the in silico docking part very well, then we can go for the wet lab things also, like the cytotoxicity tests and all, sir. So docking is very important, sir. So I think this program is very important for all the biotechnology people. And we thank as a whole to Michael sir and his team. And Vanap sir, it is a great effort from your side to invite sir and his team. And in future also, we are looking forward for welcoming sir to our NIT. And also, sir, I am going to collaborate with you, sir. And thank you so much. And also
Yeah,
to
ma'am.
your team.
Yeah, yeah, ma'am. Actually, a lot of people don't know what I was actually doing, how this all clicked. Being a Max faculty, how I got connection from all this
Great thing,
tall,
sir. This is a
tall
great thing.
persons. So
Yes, sir. This is actually this is a,
I will
yes, sir.
tell the story maybe later. I will keep the stories a secret. I will share it with everybody
I
later.
appreciate you, sir.
Okay. Oh, okay.
Yes, sir.
Now, Ram Prakash sir is online. Sir, once again, sir, Michael sir.
Yeah.
Sir, thank you. Vanam sir, thank you so much. Vanam sir, thank you. Thank you so much.
No, sir, Ram Prakash sir.
Yes,
Michael
sir.
sir is online. Michael sir is online.
Okay.
You just give a warm welcome as well as thanks for him. His lecture is over today. He has given 6 lectures in this FTP.
Okay.
Michael sir, उनके
Yes,
साथ और दो रिसर्च स्कॉलर्स हैं
Yes,
सर,
sir.
उनको थैंक्स कर
Yes.
दीजिए सर. हाँ
Yes,
सर.
sir. Sir, thank you so much, sir. Thank you.
Yeah, thank you.
हमारी तरफ से आपको बहुत-बहुत thank you, sir. Thank you so much. We are very, very grateful to you, sir. और भानु सर आपको भी बहुत-बहुत thank you. Thank you. कॉल करने वाले आप ही हैं.
We'll meet sometime.
Thank you, sir. Okay, sir. Bye, है ना?
Okay. So that was our dean students affairs. Yeah,
Okay.
Dean Students Affairs, Ram Prakash Sharma, sir. He is basically from Rajasthan. Yeah, sir. Yeah, any other participant, please join us quickly because we don't want to take more time of our experts. We want to let them go. Please join us. Your words are very important. Please thank them. Yeah, please. Participants, unmute your mic, please. I'm requesting. Sir, Biswadeep Das, sir. Biswadeep Das, sir. So may I call upon Biswadeep Das, sir? Biswadeep Das, sir. Yeah, Rashmi Ranjan, you are answering a lot of questions. Can you join?
Yeah. Good evening, sir. Good evening. Thank you, Professor Michael Gomiha, sir. It was really wonderful sessions. Actually, I am from computer science background. So although I had very little knowledge about this bioinformatics, but definitely, certainly, I got some basic background about all these. I had forgotten in my school days. I had read about these your proteins, amino acids, all those things. Again, means the way Michael taught us, it was very interesting. It was brushed up for me. So thank you, Michael sir, and your team for this. Thank you, sir.
Okay, welcome.
So Aisha Hina, are you there?
Yes, sir.
Yeah, can you join us for thanking our experts and his team?
Yeah, sure, sir. I'm audible, sir?
Yeah, definitely. Go ahead.
Good evening, everyone. First of all, I am from engineering background. My core branch is electronics and communication, and I'm doing research in biomedical image processing. So sorry, Gromia sir, I was attending your lectures, but was not able to cope up with you because my knowledge in that basic atomic theory, atoms, proteins, all this is very less. We have left it in PUC only, and after PUC, it was like some people say that if you stop learning, whatever you might have learned, but if you stop learning, then you will be like getting back to zero. That was my situation. I was basically behaving like a student who will sit and try to understand the things, concepts, like reminded me of my those days of UC. I was just trying to link the things. I was trying to put up the matters, everything that peptides, proteins, hydrogen bonding, all those linkages, all the residues, calculation part, everything. Calculation part we can do. So engineers, we are very much interested. Or equations, calculation part, everything. But the basics, I was like, I was sounding weak there. That is the reason why I repeatedly was contacting Manav sir. Sir, I don't know, I have attended all these sessions, but I don't know if I'll be able to attempt the quiz or not because my basic knowledge in this field, bioinformatics and biotechnology, is very less, sir. Only I have done my research work related to biomedical image processing, that too. But thank you so much, Gomia sir, for from such an expert like you, getting so much of basics, so much of knowledge of bioinformatics, and your research scholars also, hands off to them. That is really a big lot of applause you all deserve. You all are doing so well, and there are no words to thank Manav sir actually. Thank you so much, sir. Thank you.
Okay. Okay, thank you, madam. Biswadeep Das, sir. Okay, fine. I think sir is in meeting. Biswadeep Das, sir, again, he's a doctor from AIMS, Rishikesh. So I would have be happy if he would have joined it. But okay, no problem. But he is busy. But he is following our lecture also. Next, I will call upon Suguna Periyasamy. Whether Suguna Periyasamy, whether she is there. Srinidhi KS. Then yeah, if anybody wants to join, join. Okay, then. So then Yeah, Biswadip Das sir has returned. So, so he has his regards. I said his regards to Professor Gromiha sir and his research scholars. Yeah, sir. So, fine, sir. Thank you. We're really sad that we are letting you go. So anyhow, we don't want to take much of your time. Of course, we have taken, but still. Sir, thank you, sir. Thank you, Gromiha, sir. Sir, thank
Okay,
you to
looking
you
forward
and
to meet you again in
research
person.
scholars. Yeah, 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 sir.
Okay, bye. Bye, bye. Take care. Yeah, yeah. Looking forward to meet you in person in Arunachal Pradesh next time. Yeah.
Thank you, sir. Thank you, sir.
Okay.
Sure, sir.
Okay.
Sure.
Bye.
Bye, sir.
Bye. Thanks, Pranday and Mehta.
Thank you.
Yeah, okay, I am online. Pallavi madam, have you gone? At least you can have some discussion with the participants. We didn't have an informal meeting.
Yes, yes.
Yeah, yeah.
Yes, yes.
So,
actually, sir, as I have told you, no, this is
yeah,
a very interesting topic. Like, though people are from the different backgrounds, like some people are from computer science, some are from some other engineering background, or some are from the basic science, like you are from mathematics. Still, sir, this is the basics actually. We are now going through the different kind of problems. Like, just imagine
ma'am,
about
one request. I will.
Yes.
Ma'am, actually, I will stop recording and then again I will start the recording. Let it be in another video.